Yeah.
All right. So today we are presenting a bank management application. It is for our project of software design and analysis. In my project, my colleagues or my student fellow who helped me are Yusuf, Ahmed, Abdurrahman, and Ayman. So let me begin with the planning phase or first phase of SDLC because this is the approach we decide to use, or this is what's the requirement. In as per SDLC, the first phase is planning phase, and you have to describe what the problem is. So our problem was, or problem statement is, bank that rely on manual or semi-digital system face delays, data entry errors, difficulty tracking transactions accurately. This lead to inefficiency. It creates security risk and poor customer experience. So there was a objective was given, and the objective was is to have a bank account management system that enable customers to manage their accounts, perform transactions, and access financial information themselves, while providing administrator with tools to monitor activities, approve high value operations, and ensure the safety and integrity of banking data. Of course, we have the requirements for that. My colleague Yusuf, he'll take it over from here because he's the one who created requirements. So Yusuf, hand it over to you. Thank you.
Thank you very much, Hussein. So I was one of my responsibilities was the functional requirements. So let me start off by saying that our system supports core banking functions such as managing customer, different types of accounts, processing transactions, loans and payments, reports and audits, and finally, user roles. So, for the non functional requirements, in addition to the functional requirements, the system focuses on security and quality, which includes the secure login and the two-step authentication, role based access control, high system integrity, advanced encryption standards, and accurate real time reporting with a simple user friendly interface. So, as we can see here, this is called a fishbone diagram. I'm gonna just simply go over it. This diagram, it shows the main causes of inefficiency in manual and semi-digital banking. Problems come from people, processes, technology, data, management, and the environment. These are the causes of the problems that I'm about to list, which are the errors, weak security, and high operational risk. And for the last thing, which is the initial feasibility, which is exactly it is that we evaluated the project using six feasibility types, which are technical, operational, economic, legal, schedule, and resource feasibility. The system is actually technically very achievable. It is also very cost effective, legally compliant, and can be completed within the given timeline, which was given to us at the beginning of the project. Thank you very much, and I'm gonna send it off to my next groupmate.
Thank you, Yusuf. I will take it from here. Hello, my name is Ahmed. In this project, I have developed a front-end banking system using HTML, and CSS and JavaScript. And for this one, it has two roles, client side and employee side. I have developed the employee side. We can just start from here. We have creating a customer one. For this one, he can searching from his name or customer ID or national ID and like that. And can you create a new customer with his full name and national ID and his phone number and address. And another thing, we in open account, we have account types that current account and saving account and business account or loan accounts, all of these stuffs. And here we have a in dashing board, a quick action. In quick action, you can searching. with his name or IBAN or his Kimlink, all of these stuffs, asking from him how many amount he need to deposit or withdraw. And also we have all of these accounts and we can transfer money from one to another using the IBAN or Kimlik or name. And also we can filter accounting using the transaction history to see all the transaction history.
Recording. Yes. 1, 2, 3. Thank you very much, Ahmed. And now we are going to continue with the client side of the demo. As you can see, it's a very basic client side banking system. You can transfer money from your different accounts. For example, from your current accounts to the saving accounts, we add and we choose the value that we want to transfer. For example, 25, and we need to enter a description. For example, for payments or whatever, and we click transfer. As we can see, the money is transferred because the current account is deducted $25 and the saving account has added $25. And we can see the description here, what this payment or this transfer, what was the purpose of it and the description of it. Thank you very much. And now we continue with the next member of our group and the next phase with Ayman.
Hi everyone. So thank you for all my teammates. Now we are in the testing phase. In the testing phase of our bank management system, its main objective was to confirm that the application securely and efficiently works and manage the accounts, transactions, and financial records. So we focus on both functional testing and non-functional testing. Functional testing like opening an account, deposit stuff, withdraw and loans. And non-functional testing was especially security and performance stuff. So in our test, in the testing environment, we'll check the architecture, how our data is stored, session management, and the browser stuff. So we used also a simple architecture, HTML, CSS, JavaScript, open it on Chrome. So we used a simple web architecture, HTML, CSS, JavaScript, and we tested manually in Chrome. For the unit testing, on a key logic such as access the control, KYC validation, and withdraw limits. Then during integration testing, we verified that the account creation is correct, it works, the transaction history correctly pressed with the correct amount stuff, and signed across dashboards, so the user can see it. So in the system and regression testing is performed to ensure that the recent code that we change has not so in the system and regression testing, the regression testing is performed to ensure that the recent code or the code that we changed doesn't affect the existing features that exist before. So in the system and regression testing, we use those testing to ensure recent update didn't break the existing features. And we finished with the UIT, where stakeholders confirm that the system meets our requirements that we talked before. 24 test cases, fixed 4 bugs, and the final statue is stable, so the user can use it without any issue, any problem, meaning the system is ready for deployment. Thank you very much.
It's me, Abdurrahman. I will briefly explain the deployment phase, which is the last phase of our bank management system. After successful testing and user acceptance, the system was deployed using a direct deployment approach. This means the final stable version replaced all previous version at once. The application was deployed as a browser-based system, which allowed fast installation and reduced infrastructure costs. No server-side setup was required. The application was deployed as a web system, which allows fast installation and reduced infrastructure cost, and we used a cloud service storage. Before going live, security checks were verified, user access roles were confirmed, and data storage was prepared, backup, and rollback. Plans were also defined to handle any unexpected issues. As a result, the system was successfully deployed and it's fully operational, secure, and ready for daily use. Thank you. I would like to thank my team members, and this is our banking management system, and this is a brief explanation of it.